I'm adding a new playlist to this series, and the playlist is about Python in Houdini. And this playlist is for those who are like me in visual effects or FX, or who wanted to become technical directors like me. So we need programming to manipulate the parameters, or to create new parameters, new tools in Houdini or any 3D software. So I'm adding this playlist to this channel, and as I learn Python, I will create more videos. But first, today I'm starting new. I'm starting fresh. I'm starting with this playlist, and today I will cover the very first video in this playlist, and I'm like very excited about this because this is a new step for me too. And this will be a short video, but I will cover the building blocks of Python. It took me a bit longer to understand the concepts, but I will make it very easy, very simple for those who are viewing this, or just for me. I will just make it easy for myself. So yes, and it will be a bit easier for you if you understand like how if you are like a beginner in Vex, or you know a bit about Vex, or if you are a complete beginner to programming, then maybe it will be a bit difficult for you to understand it, but I will try to make it like completely easy for you too. So I will use Houdini for this, and I will use its Python shell, and we will just start with the very basics of Python. So let's start this video. I will just start with a new, I will just create a new window, and this window I will just say a Python shell. You can create it, and we have something like this. Or I can just create a new Python shell here, something like that. And we will work here, but first I will cover the very fundamentals of this playlist of Python. And first, I will talk about what Python is. So I can just I can just close this window, and I will just talk about what Python is. I will create a node, and I can create a new, I can do something like this. So Python is object oriented programming, OOP. I will say object oriented programming. And whatever we do here, like in Vex, we manipulated the geometry, and geometry in that case points, vertices, and primitives, and we were manipulating those geometry attributes and other data by Vex, right? So in that case we were what's the word, okay, so in that case we were manipulating the data by Vex, and here we are manipulating the data by this object oriented programming, and here the data is objects. So we are manipulating the data, but we call that data here object, and everything we will work with, we will call them object, because everything in Python is an object, and you will understand it clearly in a second. So when I said object oriented programming, and everything here is an object, first, like in Vex, we had data types, right? So here I will start with data types, and then I will go into the objects. First, you will understand this. We had a string, right? So string is a text. String is a text, right? and whatever we type in here, like whatever the form of text here, is a type of data which we call string. String is text. String, we call it text, right? We had integers, float, and other types of data there, and we have the same type of data here. We have float, right? We have integers, and we have other types of data. And we had, it will give you error, just ignore this. And we also had some type of functions there, like chf, chv. So what we were doing there, we were manipulating the data or creating more parameters by these functions, right, in vex. But if you don't know about vex, so first we will cover the data types, then I will jump into the objects and everything. So data types, we have string, text, we have integers, I will say numbers. So numbers are a data type. It is a major data type with these subtypes of data which we call integers, float, like this. So we have integers and we have float, right? And integers are, I will say, integers are 1, 2, 3, 4, 5, 6, right? And we have float, which is a number but in decimal, 1.2, 1.3, 1.7. You can like type, if there is a decimal, that means it's a float value. And even 1.0, 2.0, 3. Whatever is, if you even have 0, that means it is a type of float value. So now we know something like this. And when I said object oriented programming and everything is an object here, that means these numbers, these also object. And by object, what I mean by object, I will create another node and I will zoom in a bit and I will say object. So object is a type of container which has a data plus a toolkit which it can perform on itself. It's a bit complicated, but you will understand it. Object has two things, data and a toolkit which it can perform on itself to do something, to give us a value or to perform an action. So for example, when I said everything is a data and we have everything is an object and we have data types, so when I said these data types are based, like these data types are objects and these data types are differentiated, are separated by their specific data they can store and the specific function they can perform. And I will say, when I'm saying that I have a data type something like integer, right? So I will say 4, 5, 6, 7, 8. These are integers. But what can they perform? They can perform their specific functions. They can perform their specific function and we call them methods. It is a bit complicated, but when I will just connect everything together, then you will like understand it more clearly. So first we have data types. Data types are objects. I will just create I will open puref, right? I will create a node. First we have data type. First we have a data type. Everything, I will say data, okay, and I will say draw. So first we have at top is this, right? This is something like this. Python has objects, right? And this object, I will say, has I'll create another. I want this. Okay. Object has two things. First, functions, and second, I can copy and paste this, and I will say it's data type, right? So Python, everything is based on object in Python, everything is object in Python, and these objects have two things. First, data type, and second, functions. And these functions are what these data types can perform. So if I'm saying that I have a car, right, or I have a hand, right, what function it can perform? It can wave, it can pick something up, right, but it cannot punch a hole through a wall, right? So this hand can perform an action, right? It can pick something up, it can you can punch the wall, but you cannot create a hole in the wall. So this hand is not for that. So it has its specific functions it can perform, right? So this hand, I will say, has its functions. First, it is data. This hand is a data, right? It can perform some specific functions, like what? It can pick things up, it can wave, right? But when I'm saying hand create magic, it cannot create magic. That's not the possibility here. So it can create functions, specific functions that this object can perform. And these functions we call methods. These functions we call method. So we have object, they are data type, and they can perform different functions. Now I will go into this data type. So we have data, right? And these data are separated, differentiated by the types of functions they can perform, right? And by the type of data they can store. Like, let's talk about numbers, and in numbers we have integers, right? So integers is a type of data, right? And this integer stores what? 1, 2, 3, 4, 5, 6, right? And I will talk about a function these integers can perform. This is data. I will just I will draw something. This is a data, and the function they can perform is dot bit length. This is the function it can perform. And if I break this down, I will just say that I will just create another. This is a function it can perform, and this part belongs to the number that you want to perform the function. And I will say this is the data type. So here is the data type, and this is the function. This is the function it can perform. So this integer can perform this function, for example, and I will say 5. I'm not good at typing these different symbols, but I'm good at typing the everything else. So this function, this is the data type, and we put this dot, and after that we put the function we want to perform. And just forget about these brackets, because we are first learning about the building blocks of this. So this data type is integer, right? It can perform this function, and this bit length gives us the value, like the computer value, the bit form of this number, because in computer language everything is 0, 1, 0, right? So it can give you this function, it can perform this function. But if I say, if I just copy and paste, and if I say string, if I say this is a string, this is different type of data form, but this string don't have any bit length because that's just a text, and text don't have bit lengths in computer language. So this function cannot be performed by this different data type, right? This can be performed by this data type, and but this cannot be performed by this data type. And right, we have this integer functions and we have different types of data. But also one thing here is that these data types are, we call them classes. We call them classes, and these classes, which are data types, are based on the type of data they store and the type of function they can perform. For example, it's simple. We have string. This means we have this data type which is a text. It perform upper. This means this upper will make this string into uppercase, and you have similar a lower, which will make this a lowercase, but it's already a lower, so that will just output the same string. So these data types are based on, I will just create a note, data types are based on what? Based on the type of data they store and the function, and I will say methods they can perform, right? And functions, if performed by the same like data type, we call them methods. And methods and functions are different, but here these are methods. Methods means the function that can be performed by a specific kind of data on itself. Like if I'm saying string dot upper, that means this function is happening on this data which is string. So this string, whatever the functions that this data type can perform, we call them methods. We have global functions, right? We also have global functions, and we call this global functions, like they can be performed globally, they store globally, like not like this. I told you everything here is an object, right? And objects store data and its function. If I'm saying this hand, this is an object, it has its data first, it has its function stored in this object. But if I'm saying that this thing, this is a function that exists in this in this part, in this global, in this like spatial in this spatial area, right? So this is a function that is less revolving around here. You pick it up and you perform this function on this hand. So this is a global function, but this hand has its own functions and we call them methods. But this exists globally. So here we have global functions like ABS, we call it absolute, and this type of function only works on integers, like only works on integers. So I will say this absolute, I will create a node and I will say this works on these type of data, this class, and here the class is integer, right? This cannot work on strings because this function works on different type of data like this bottle, and bottle here is a string, is integer, sorry, not string. And if I'm saying that, what does this function do? It doesn't matter right now because we are learning. It just gives you a positive value if you if you say -5, it will just output positive value, which is +5. So you know things now, and I have created a note about this, and you will understand it clearly. Then we will do some work, and we will get our hands dirty with the Houdini Python. We will write something, then we will just say if what is happening. I will talk about variables because they are also important, and they are like very easy to understand. So we have objects. Objects in Python, everything is an object. An object is a self-contained package that holds two things. First, data, the value, what the object actually is, like the number 5 or text hello. Like the object, what type of data it contains, right? The value, the toolkit, methods, what type of built-in methods it contains. Like this hand can pick things up, it can wave, but it cannot punch a hole through a wall. We have classes. The classes are the like the blueprints. I wrote here blueprints, and here blueprints means classes, type of data, what kind of function they can perform. Like it is like what kind of object it is, like what type of data it has, and what type of methods it can perform, right? So Python separates data into two different categories called classes. We divide them based on what kind of data they store and what kind of function, what kind of specific toolkit or function they store, right? And for example, the string class handles text hello, right? It comes with a toolkit that includes method like upper, this, so that will make it uppercase, right? Second example, the integer class handles whole number like 5. It comes with the completely different toolkit that includes method like dot bit length. So what we'll do, it will convert it into the bit length or 0101 in the computer language. We have instances. I haven't talked about it. So you see this data, like this type of data type has 1 2 3 4 5. So I will create something like, and you will understand it real quick. We have integer. What is this data type? And we call it class, right? What it does, it is an object. First, it stores its own toolkit. Second, it stores its own type of data, right? That's why we have separated into class. This integer, what type of data we have in integers? Numbers 1 2 3 4 5 6, right? You see 1 is an integer, second is also an integer. I will say 1 is also an integer, second is also an integer, third is also an integer, and 3 is also an integer. All these are integer, belong to the integer class, right? This belongs to this class, and we call each instance of this class. These are different type of instances of the same class, same type of data of the different class, but like different numbers. Like I don't have the word to explain this, but this is a same type of data, but they are different. Like it belongs to same class, right? For example, when we copy an object like 1,000 times, we create instances, right? So same type of data, right? But it belongs to the same class. You understand this? For example, another example, string, right? We have string, and string contains something like text, right? I will say name or my name, Tejas, right? So these are instances of this string class. I hope you, I know you understand this, right? I don't need to explain it more. So we have instances also. Okay, I will just open the notes, and you will see we have instances, and we call these buddies or copies. Definition: an instance is an individual specific copy of a class. Think of it like the class is the blueprint for a house. An instance is the actual house built from. What I wrote, this is a bit complicated. Actual house built from it. Nah. I don't want to. No, just remove this. And says the individual specific copy of the class. Just remember this. It will make it a more bit complicated to understand, so just remove it. In Python, a class is an integer, but the individual number like 5, 7, 8 are instances of that class. They are all peers, they share the exact same class, and integer blueprint and can use exact integer toolkit. And yes, they are like the similar type of data, so they can perform the similar the type of functions, the methods that that data can perform, right? And we have methods like in because data lives in classes and its own instances, we use the dot rule to execute the specific toolkit. Yes, when I told you about that global thing, right, the global function, and when we use the class and its own specific type of method it can perform, so we are now using it in action, right? So you can read it like the example I gave you. 5, we are we are converting it into the bit length and how many bits are need to make 5. Rule a string instance cannot use an yes, this is the main thing that I talked about in this video. A string instance cannot use integer tools, it will use the string tools, right? If there is a global function, it can only perform on a specific type of data, a specific type of class. Open Houdini and just create something. I will say 1, 2, 3, 4, 5, 6, right? Let's perform ABS. Let's pick this global function first. So when I set absolute, and you can say like -5, and when I hit enter, it will give you 5. The output here is 5. That means this absolute is working on the type of कौन सी? हाँ बंद कर दो. अरे कोई सी बंद कर दो यार. अरे okay, so this absolute is giving us a 5, right? So absolute -6 will give you -6 will give you this, right? And you can also I talked about, let's say first talk about string. So this is a data type string, and you can write this as this, or you can write this as this, and it will give us an error. It will give you an error because we are just playing with this. So this is the type of data we have. And also I want to talk about variables. So as in vex, we store float as float or integers, but here we store something like this. We don't need to tell them what type of data it is because this Python is smart. It knows what type of data it is because that data is a part of object and everything revolves around object here. So I'm saying that 6, and you don't need to put this to end the code because here every line is ending. If you hit enter, then you are ending the code. You don't need to put this in the end as we do in vex. So you see, what I'm saying, I'm storing a variable, data in this variable. So variable, points a specific type of data. It's just storing the data in this variable. It's just a sticky note. It's just a name to this data type. If I'm saying x equals to 6, and if I'm saying x, so it will give you value 6, and if I'm saying x plus y, it will give you an error because we don't have y. What is y? So it is just pointing a data. So if I'm saying y here is 12, so it will say, when I say y, it will give you 12, and when I'm saying x and I'm saying plus y, what it will give you 18. So what is happening here? X is just a label that is pointing to this data, and y is a label that is pointing to this data, right? And what we can do, we can perform different actions like we did. like string, or I can say x equals to string. So when I call x, it will give you string. And when I say I want x dot upper, it will give you string. Now you see that x, we are pointing towards that specific type of data, and it is making it uppercase, right? And I guess for this is enough for this video, because I don't want to make it more complicated. So I hope you understand this blueprint, because this is the base of Python. This is how Python works. We are working with objects. And when we move forward, when I move forward with my learning, I will understand new methods, new tricks to make this more simpler. So, but I think this is enough, because yeah, I guess this is enough, because when I was learning, this was a bit complicated for me to understand it first, but I have made it like purely simple. You won't find it more simpler than this, because this is the whole blueprint for this language. So this is it for this video, and I will see you in the next video of this playlist.